So hello everyone, welcome on Kotlin Not-to-Do List, your today's vaccine against bugs, crazy ideas and angry coworkers. This presentation is based on my book, Effective Kotlin, when I describe best practices for Kotlin development, based on what community creators and other books in the topic says, and it has many items of what should we do in Kotlin, but here we are going to concentrate particularly on what we should not do in Kotlin. I divided these subjects into three main scenes of Kotlin developers, and the first one is hiding too much. But let's start with something we all love. Type inference, something that was introduced in Java sometime after Kotlin introduced that. When you see it's a number, you do not need to say explicitly it's a number, it's clear. The same with a string, with a list of integers, etc., etc. But what if this type is not clear at all? Instead of confusing your coworkers, it's nice to specify it explicitly for the sake of readability. Setting the type is for the sake of readability, but there are also security concerns around setting type. And to understand the first problem, you need to understand that type inference is exact, meaning that if you make a variable and initialize it with some value, it will take the lowest possible type, the concrete type of zebra. And so you cannot set anything that is having an upper type. It's especially annoying when you deal with sealed classes or things like error and response, or a list of sealed classes, potentially sealed classes. Clearly, the solution is to set this type explicitly, but not always you can. And to show you a situation where it might be a true problem, I would like to tell you a story. So imagine that you have a library where you define an interface to produce cars, and you provide the following interface. Although, since you live in a communistic country, you have one particularly popular car that is produced by most factories. So by making their lives harder, you make it the default. And then you think, hey, this type in here is not needed. I can just skip it. And sometime later, another developer thinks that this type is not needed, and he or she skips that as well. And congratulations, now your factory can produce only one type of car. This story happened in Poland some time ago, and I don't want it ever again. So the general rule is to not expose inferred types. We'll see it a little bit later again, but the general rule is that if you have a public API, it's good to set the type explicitly. It was even in Kotlin 1.4, they introduced a strict mode. It's primarily for library creators, and one of the things it forces you to do is making explicit types on public API, so exactly the implementation of this rule. Just because you are not a library creator, it does not mean you should not do that, because if you are having bigger services, probably used by many teams, these members will not be familiar so much with the API, and it's very nice to make type explicit. Another side of this problem is null safety. So the problem is when we interoperate between Kotlin and Java. Java do not have a strict null safety mechanisms, and so it uses annotation to inform if something is nullable or not null. We trust those annotations and we translate one-to-one to Kotlin's nullable and not null type. But what if it is not clear at all? So we do not like this kind of situation, and we avoid it as much as we can using a variety of annotations. This was actually the first thing that happened in Android when they started supporting Kotlin. They introduced these annotations in many places. But if you have this unannotated type returned, what you have there is so-called platform type. So platform type is a type coming from Java that has unknown nullability. So it haven't yet decided. It might be nullable or not. So you can set it as not nullable or as a nullable. What does it mean? It means that it's platform types are very dangerous, and we would like to eliminate them as soon as possible. To understand why, I would like to first show you those two code snippets. They both get object from Java, and they both use it unsafely. So in both cases, we'll have null pointer exception if it is null. But in the first case, we specified the type explicitly. And as a result, we'll have null pointer exception thrown here with a good message explaining where does this null come from, and it will be clear to you how to fix it. On the other side, the second null pointer exception comes from some expression. It gives you only the line, no useful message. It might be, it will be harder to find, and it is also more dangerous. Also, especially crazy situation, if you know it can be nullable and you use it safely many times, it's very dangerous because some other developers might come there and need to use it. The first suggestion IntelliJ gives is to use it as not nullable, and bam, he introduces a mistake that could have been easily prevented if you would set type. So the general rule is to eliminate platform types as soon as possible. There is another part of the story. We are getting back into specifying types in the public interface. Imagine that you got an interface, user repo, and with a method with inferred platform type. So this is platform type inferred from Java. This is a especially dangerous situation as this type can be both nullable and not null, meaning that on the definition side, we can specify it as nullable and return null. And on the use side, we can specify as a not nullable and consume it as a not nullable. And this way, it is possible to have null pointer exception on a runtime without any warning or error, with null thrown from returned from Kotlin. So, crazy thing, but there actually is a warning that should not be ignored, that the open function should not have platform type inferred, and we should respect it and set the type explicitly. Okay, another place where people hide things is when we use implicit receivers. So this is actually a nice way how it can be used. This is a perfect way, perfect situation where we should use apply instead of repeating this variable many times. So this is an advantage, but overusing these scope functions might be very dangerous. And here, and also hiding this receiver, this can be both used implicitly and explicitly. So this first function actually comes from the receiver, from this, but it is not explicit, so it might be confusing. It's not clear where does that come from. I argue that in most cases, it is beneficial to use this keyword to make it explicit. Where does this come from? If it is an outer receiver, then you need to use a label to say which receiver it is. Okay, so here is a situation where we use apply in an incorrect way. So this is a code snippet. If you would like to test yourself, you can stop a video right now and think about it. So the question is what will be printed in here, and the answer is that even though we might expect that we should print created child, as we call it on child, in fact, the actual result is created parent. So how so? We are in the scope of a child. How so we are printing created parent, which is referencing to this class? So the answer to that can be found if we use explicit receiver. So if we use explicit receiver, we cannot call name at all because receiver is nullable. So actually the problem in here is that apply is called on a nullable node, okay? And we cannot call name on a nullable variable. And so instead, Kotlin implicitly used an outer receiver, which is the name in here. So it can be fixed using a safe call, but it's not a good fix. The best fix is not use apply in these kind of situations. And additional operations and mappings should be done using also or let. Also is they both require you to use reference explicitly as they use it instead of this, and they are appropriate for this kind of situations. We should not hide receiver when there is no actual benefit for that. Okay, another side of this problem is member extensions. So you might be surprised how often they are used, and they are definitely overused in Kotlin. Member extension is an extension functions defined inside a class. Many developers, when they do that, they argue that they want it there because it belongs there and they want it to be visible only inside this class. It is not really successful as it can still be used from outside of this class, only in a weird way. If we want to limit the visibility of something, we have visibility modifiers for that. So a private, for instance, and we can lift this function outside of the scope of the class on the top level. Now it can be, it's more readable, you know where it belongs to. It belongs to a string, not to a phone book, and you can reference it if you need. So referencing is now possible. Member extension cannot be referenced. It's not supported by Kotlin programming language. So why member extensions are bad? So first of all, implicit receivers, we do not know where something comes from. So here we have A both in A and B. So where does that come from? I can make a poll right now, but we have a delay between my stream. So it actually comes from A, but it might be very confusing. If we're supposed to modify something, if it's not a pure function, what should we update, A or B? I don't know. One Rabin will say A, another will say B. Who knows? I see that this practice is quite popular in the backend to make this kind of mappers, so to JSON, from JSON, etc., etc. Again, if they do not belong to this object, this class, if they should be lifted outside, it is more clear, it is less confusing. We are not asking ourselves why is it there. It's clear that it's just some mapper that is that we want to be visible only in this class. And if we do use these things from this facade, then I argue not to delivery detail, and delivery detail should be passed as an argument. And if your argument, if your need is to move it on the end of the expression, then the solution is to use let, which is like a mapper for a single object, and it works perfectly in here. Okay, another sin of Kotlin developers is choosing short over readable, and there is a popular misconception in programming that the conciseness is a value in itself. And for everyone who believes in that, I have a great news. So a game of life, a typical coding challenge, I couldn't manage to write it in a clear way in less than 10 lines in Kotlin. But it can be written in language like APL in just a single line. So your first reaction is probably, wow, that is short. And the second one is probably look at your keyboard and thought, hey, I do not have most of those characters on my keyboard. So if you like APL, you probably will spend some time on the character map on Windows or, or copy pasting those characters from internet. There are more such languages like J. They are very concise. They are victors in coding golf challenges, but they are not readable at all. The difference between readability and conciseness can be seen in those two code snippets. The first one and the second one, they both do more or less the same. You can say they do the same. The first one, I asked some developers of those developers told me that they prefer the second one. I might say it was like 30–40%. Many of them argued that the second one is better because it is shorter. And this is true. It's actually exactly 8 characters shorter. And we achieved this stunning result using only a few Kotlin features like save call, take if, let, bounded function reference, Elvis operator, and this weird expression after Elvis operator. I truly feel sorry for all the juniors and practitioners who join your team and are asked to work on this kind of code. On the other hand, the first snippet can be is readable and is clear for all developers, even JavaScript developers. But I believe it's also much better for us. So if I would need to read the second code, I would read it slowly, line by line. The first one, bam, I see and I understand it. If you need to change the code, the first one, trivial. You can just add something to each branch. It's not a problem. In the second case, well, you need to refactor first, and what you have on the end is not better than, it's even worse than what you had in the beginning. And finally, those two code snippets do not actually behave exactly the same way. So when you use strange connections of features, it's really to miss small differences. And now I will ask you the question, what do you think is the difference between those two? And again, since we have a delay, I will not wait for the answers, but you can stop the video and think about it. And moving to the answer, the first one shows error when person is null or when this person is not an adult. The second one shows an error when person is null, when person is not an adult, or when show person returns null. What is possible? And well, good luck finding. Yeah, sorry, I am back. Finally, I believe that the first code is definitely better. It's much more readable and it should be chosen. We should not complicate our code just for complicating our code, unless we want to show that we how well we know Kotlin features, but it is never a good motivator for doing something on the real life projects. This rule, designed for readability, not for conciseness, not for using crazy features, can be applied on many spheres. One of them is to not operating or unit nullable. I haven't seen it for quite a while, so I'm very happy about it. But at the beginning, I've seen it in a few places. At the beginnings of Kotlin popularity, I've seen it in quite a few places. And it was actually asked to my friend on an interview. Interviewer asked, hey, why would you want to return unit nullable? And the answer turned out to be that it's like a Boolean because it has two values, unit or null, but it has this Elvis operator that you can use and other Kotlin nullability features. So this is actually a terrible answer. We do not want to write code like this. Here we operate on a logically Boolean operators. We have Boolean operators for that and Boolean support for that. And we should prefer to use a Boolean instead of nullable unit. Another implementation of this rule can be found on a story from my workshop, as I conduct workshops about Kotlin quite regularly via KT Academy. And on one of my workshops, I asked as a small warm-up exercise to the group to implement a factorial function. And factorial is a product of all the numbers from 1 to this number. And this is a simplified solution. That can be quite nicely used in the code to calculate a factorial of some number. But someone noticed that this is not how we call factorial in mathematics. In mathematics, we call factorial using exclamation mark. And we cannot implement it in Kotlin, but if we make a small modification and allow this exclamation mark at the beginning, we can actually do that. To do that, all we need is a not extension function. Not extension function on integer, as its name suggests, should not be used like that, because not is a logical operator that means negation, and using it on a number does not make sense. We should not use operators like that. And you can always call operator from its original name. So someone could just say 6.not, what makes it clear that it is definitely not how this operator is designed to be used. So we should not do something like that. We should make our operators always consistent with their function name, with their meaning, with their mathematical contract. And so every operator is having a function, it should be consistent, and you should not be worried that someone uses operator from behind its name. This is a place where people can do crazy things. This is Eric Hellman, a known personality in the Kotlin world, programming world, making fun of that and making extension that lets you remove some character using rem operator. This is a clear trolling. This is something that we should never do. It's much more readable to use operator like remove all. Please do not make Kotlin another Scala. Okay, and the third part of our presentation, and the third biggest sin of Kotlin developers is disrespecting contract. And when you take a look at a code like that, you probably feel that there is something wrong with that. Everything is public, and we all pretty well know that whatever does not need to be public, we should make less visible, for instance, protected or private, like in this case. It is clear for most people, but when we need to explain it, it's not so easy to explain it. I dedicated a whole item to explain the reasons behind it. In short words, private makes your API smaller, and it's easier to maintain smaller interface. It's always easier to open something in the future than to close something that is open, because nobody likes when you steal their toys. It is also about managing your state. So when variable is open, when variable is public, you don't know where it is used, where it is changed. You do not have control it. You cannot promise what is that the state is consistent with other elements of your functions, with other parts of the state, and it is much harder to track changes. It can be modified in many classes. So changing this object is definitely harder. But we do not use private modifier to make it impossible for other developers to use it. Just take a look at this example. Here we have a private function. You might think that it is impossible for others to call it, but well, it is not. All you need is to reflect for a moment, and you can see that you can make a reference to this class, get its elements, find element by name, make it visible, and call it however you want. If your argument is that people will never do that because it's too hard for them, I can make an extension function, and now it's like easy like that. People will not do that because it is breaking contract of this function. The creator, by saying it should be private, stated that he or she does not want you to call it from outside. And if you break this contract, it's your problem. If you break this contract, a creator can change whatever he wants inside, and he does not care about your implementation. When you disrespect contract, first, you are not sure how something works because you are entering undocumented, probably untested areas. And second, you don't know how it will work in the future versions. Your implementation might stop working at any moment, and it's your fault. The creator will not support those who break contracts. One way is visibility modifiers, but there are many other ways of creating contracts in Allegro in such a big systems. Like we have many ways of defining and specifying contracts. Contracts are on many levels, on the API level, on the events level, on the systems level. But when you think about code, we primarily defined contract by documentation and by comments, except by names and domain and things like that. Also, to a certain degree, by tests. Tests tell you how something can be used, but well, we should not expect our users to read our tests. So it's rather to keep contract. And on the other side, we should respect contract. So when contract is stated, we should respect it. And here I have an example from standard library. So practically all functions from standard library has a really good contract. It's concise and to the point. It tells you exactly what you need to know and nothing more. What is great, because on one side you are not, you do not have information you do not need, but on the other side, creators, but not specifying some things in contract, leave themselves a freedom to change it in the future. So here we return some interface list. Creators can replace the actual list that is returned with anything at any point, and your implementation will work fine as long as you are consistent with contract. How this contract can be broken in many ways. For instance, someone might use a knowledge that collections that are returned are actually Java collections. Java collections implement the Java list interface, and Java list interface translates to Kotlin mutable list, and so it is formally to do something like that. This is a very bad idea for a few reasons. First of all, it will not work because add is not supported by actual collections returned here, but there are some methods that might work, like set. But anyway, it's a very bad idea because even if you manage to hack it and your implementation works right now, you don't know if it is not going to change in the future. It might change with any version. Maybe they will replace actual platform collections with persistent collections they implemented, and now your code is not working. So it's not a good idea. It's definitely a bad idea. A proper way to do that, a way that is consistent with contract, is to use functions that are, well, they are on a list, they are properly defined. It's perfectly valid to use them. Okay, there are a few contracts that are famously known and that we need to respect in JVM platform. One of them is equals, the contract of equals. A long description, but quite intuitive for most people. But I already seen a few ways how it can be broken. And here I would like to play with you. Again, we have a delay, so I will just give you a moment to think about it. So here we have a complex number that can be compared with another complex number, but we also made it possible to compare it with double, as you know, double is like a complex number, but without an imaginary part. And so what is wrong with this code? So in a live stage, I would make probably some conversation with you. Now I will just tell you that this code is not symmetric. What does it mean? It means that complex can be equal to double, but double cannot be equal to complex. So what's the problem with that? Imagine that we have a list with a complex, and we check if it contains double. So what should be the result of that? I don't know. I mean, it all depends on how this collection is implemented, and it might change at any point. So I don't know what's the result. It might be different on different platforms. It might be different on, I don't know, at any point. We just cannot trust this collection. It's like we cannot trust it. And the same we cannot trust contains, set, assert equals, everything that uses this equals, because we do not know if it checks under the hood if object A is equal to object B or object B equal to object A. Okay, another example how it can be broken is this one. So here we have a time that can represent now, that is always now, or some concrete point in time. And so we have millis that based on that gives us either current time millis or millis arg, and equals that compare them. And again, what is wrong with that? So you can stop and think about it, but the problem is that when you compare, first of all, when you compare two is now, you never know if it is going to return you true or false, because even if you compare the same now, the same point in time with itself, it asks millis asks current time millis, and it's kind of a random if this is the same millisecond or another millisecond already. So this one gives sometimes true, sometimes false. This one nearly surely will give you false. So this implementation is not reflexive, not consistent, and it connects to another item from the book. I cannot trust contains, set, assert equals, nothing that uses equals under the hood. It connects to another chapter from the book to prefer class hierarchy to tagged classes. So this is a class that represents two cases, either now or current or point of time. It should be a type hierarchy instead of a tagged class. So we should not, put all those cases in a single class. We should separate them into hierarchy, perfectly sealed class, and that can be their point of time for now. This code will work perfect, will work, the equals work, is going to work well, and it is much better defined. It is also much shorter, by the way, and much more readable. Okay, similar story with hash code, and again, a small question. So what's wrong in here? I actually think it's quite easy. We have equals, but we do not have hash code. That means that even if two objects are equal to each other, if they are in a set, and we have one of them, we check if another one is in this set, they are equal, so it should return true, but it returns false. How so? Because hash set gave them different numbers, so they are like in a different buckets, so they cannot find each other. we need hash code always consistent with equals, and if it is not, we cannot trust anything that uses hash code under the hood, that is set, map, etc., etc. We actually have a good warning for that, so it should be also clear. But many newbie developers solve this problem by returning a constant number, and I would like to show you why it's a very bad idea. So here we have a properly implemented name, and a name with a hash code equal to a constant. And imagine a situation when we have a set with thousands names. In the first case, when we produce this set, we used equals exactly 0 times. This set was equally divided into different buckets, and we didn't need to use equals at all. In the incorrect implementation, we had to use equals 50 millions of times. So this is the cost of incorrectly implemented hash code. It's because they all land in the same bucket, and we need to compare every single one with every single one. Hashing does not work at all. If you want to check if something is in a proper set, if it is, 1 equals. If it is not, 0 equals. For the incorrect set, if it is there, on average, number of elements by 2, because it compares with them one by one. In the second case, you need to compare them with every single one, so it is the number of elements plus 1, which is an implementation detail. Okay, also Kotlin features have their own contract. So when you look at something like that, you might feel there is something wrong with that, and you might think, what's wrong with that? The answer is that we are using property to implement an algorithm. So this is clearly some kind of an algorithm. We iterate over this tree, it has some complexity, it is a behavior, and behavior should be represented by functions. Properties should represent state. So properties should not have a complexity, should be immediate, should not call any repository. Properties should just represent state. This is a clear function, and we should use function to represent it. On the other hand, I don't want to see any getters and setters in Kotlin, because every property is getter or getter and setter in Kotlin. And so if you need a getter and setter, you use property. Property can be open, property can be overwritten, property can have custom getter and custom setter. Property is a getter and setter, and we use them to represent state. We do not define functions like getName or setName. Yeah. And finally, functions. Some developers have habits from Java to represent behavior using interfaces, like in here. This is not a good practice. In Kotlin, we represent a behavior that we want to pass using a function type. And so in here, instead of this interface, we should have properties with function types. It gives us, it's more idiomatic. It's the way how we use Kotlin. It gives us more flexibility, and it is also much better supported by Kotlin programming language. So to create the interface, you need to create an object. To create a function type, an object that implements function type, you can use lambda expression, anonymous function, function reference, bounded function reference. And also you can create an object that implements function type, because function type under the hood is just a special interface. Okay, and that's it. The 3 big sins of Kotlin developers is hiding too much, choosing short over readable, and disrespecting contracts. For the reference, here are all the items I used on this presentation, and effective Kotlin can be found on the LeanPub, I stopped the distribution of the in paper versions. I currently only give them to my attendees of my KT Academy workshops, but I hopefully will resume distributions once once the pandemic is over. Oh, and if you want to have sound for your company, write me an email to marcinmoskała@gmail.com to Polish companies. I think I will consider sending you some. So yeah. Also, as I said in the beginning, I work for Allegro, which is, I believe, the biggest base of Kotlin developers. We have like 800, 900, maybe 1,000 microservices, most of them in Kotlin, like 1,000 developers, I believe, most of them developing in Kotlin. So we are very, very pro Kotlin. And I must say that I'm stunned with the level of good practices in Allegro. We are very much into development, into modern technologies. And I myself really enjoy working here. So I'm not saying that because I have to. I'm saying that because I really think it's a nice place to be if you like to learn. Okay, and that's it. Kotlin Not-to-Do List. I am giving back the voice. Are there any questions from the audience?